Hi, welcome to my video on review of extra inequalities. And as in my previous reviews on my units, you can treat it as a quiz, and this one is marked at a 41. So you total up your marks on each page and you add them up and you get a mark at a 41. Let's do the review. Solve and graph. Notice we have an inequality which is less than, but we have many brackets, so by PEMDAS we have to simplify inside of the brackets first. So inside of this bracket right here, I have to simplify these expressions. So I multiply first, so I get a 4x minus 8, negative 3 times x, negative 3x, negative 3 times 1 is plus 3, less than, and inside of there's double set of brackets here, so I'll do this one first. And again, by PEMDAS, I have to work the inside of the brackets first, so that gives me 2 cubed. And I have to get, that's a 6, so that's simplified. And we have a bracket here, so I'll simplify this. And I have an x subtract 2 times, so I multiply first, so I got a negative 2x plus 6. Now that I have all the, or part of the brackets done, I have to keep simplifying by PEMDAS. So inside of this one, I have 4x minus 3x is x, negative 8 plus 3 is minus 5, less than, and inside of this bracket, I have to do the exponent first and then subtract. So that's an 8 subtract 6 is 2. And then I have to do inside of this bracket, which is x subtract 2x is negative x plus 6. Now that I have all the brackets simplified, I'll multiply by distributive property. Negative 3x plus 15 is less than, and I have 2 times negative x plus 6 gives me negative 2x plus 12, and that gives me negative 3x plus 2x less than 12 minus 15, so that gives me negative x is less than negative 3, divide by negative 1, and I have x, and because I'm dividing by negative, greater than 3. And that's fully solved. Now I have to graph it on the number line. So I have x is 3, and notice it's not equal to, so it's a hollow, and greater than is to the right. So there's the graph of it, all real numbers to the right of 3. And another way to write that would be 3 comma infinity open. So this is open. These are saying it is open. 3 is not included, and it keep on going to infinity. And there's 8 marks for this, so if you simplify each of the brackets, you get a mark. If you multiplied correctly and got this step, you get a mark, so that's 4. If you simplified and got here, that's a 5. And then if you, or give yourself 2 for simplifying this, and if you graphed it correctly, if you left it a hollow dot and you shade it to the right, you get 2 more marks, so 8 altogether for that question. Let's go with another one. Notice now we have an inequality which is less than, but we have fractions. So this is factored into 2 times x minus 1. And because we have fractions, we have an LCD, which is rational expressions. So the LCD is 2 times x minus 1. So I'm going to multiply each part of the equation by the LCD. So each part of the equation is multiplied by the LCD. What happens when you do that, you cancel your denominator. So this denominator cancels here, and I get an x minus 9. This denominator cancels here, and I get 2 times x plus 3. Less than, the 2 cancel, and I get an x minus 5 times x minus 1. Now we have to simplify this, so that's, I have to multiply before I add or subtract. So I get a 2x plus 6, and I do the FOIL on this, and I get x times x is x squared. Outside is negative x, inside is negative 5x. Add negative 6x. So the outside, inside, and the last terms is negative 5 times negative 1 is 5. Now I have a choice. I can move everything to the left side and have it equal to 0. So, or what I normally do is simplify each side first. That makes it easier. If you simplify each side, then when you transpose, then it's easier. You have less to transpose. So that's x squared, make it a minus. That's a 3x stays plus. That's minus 6 becomes a plus 6x minus 3 minus 5 less than or equal to 0. And we simplify that. Negative x squared plus 9x minus 8 less than 0. We do not want to have a negative x squared, so we multiply everything by negative 1. So we get x squared minus 9x plus 8. And because we multiply by a negative, we change the inequality to a greater than. This is a quadratic, and a quadratic hopefully is factorable. And we have x and x. Factors of 8 to give you 9 are 8 and 1. So we have a negative and a negative because the product is positive, the sum is negative. And that means that we have x minus 8 equals 0, or x minus 1 equals 0, x is 8, or x is 1. Notice I made it equal to 0 to get the zeros. If you pretend you have an equal sign, then you find the values of x which will make it equal to 0. That means that we have, on the number line, we have an 8 right here, we have a 1 right here. So we pick up the values that'll make this inequality. But we got to be careful, because when you deal with fractions in it, with inequalities, the denominators can't be 0. So we don't know what's going to give us 0, so we got to be careful. And that means we go with, I'm going to go with a 9, that's greater than 8. I'm going to go with a 2, that's between 1 and 8, and I'm going to go with a 0. But these numbers can't be checked in this, they have to be checked in the main inequality, the original inequality. So let's go with x equals 0. We'll check with x equals 2, and we'll check with x equals 9 in the main inequality. So let's put 0 in here. So put 0 here and here, I'll get negative 9 over negative 2. Add on, put a 0 in, I get a 3 and a negative 1. And less than, I put a 0 in here and I get a negative 5 over 2. So that's 4 and 1/2. Subtract 3, less than negative 2.5. So 1.5 is less than negative 2.5. No. If I put it in here, it would have made it negative. Sorry, if I put 0 in here, so my mistake. If I put 0 right here, I would have had a negative. Put a 0 here, would have negative. Negative would have had a positive. So because it's greater than, I would be selecting it. But again, cautious. When you got inequalities with fractions, you should check back into the main one. Let's try a 2. What happens? 2 here, and we put 2 in, we get negative 7. Put 2 in here, we get a negative 7. Put a 2 here, we get 4 minus 2 is 2. Put a 2 here, we get a 5. Put a 2 here, we get a 1. Less than, put a 2 here, we get negative 3 over 2. So I sub the 2 in, so that's negative 3.5. Add on 5, less than negative 1.5. So that's 2, oops, almost added wrong. 1.5 is less than negative 1.5. Nope, so that's not true. So greater than 8, let's see what the 9 will do. We put a 9 in here, we get a 0. We put a 9 in here, we get 18 minus 2 is 16. We put a 9 in place of the x here, we get 12. Put a 9 here, we get an 8. Less than, put a 9 here, we get 5 over, put a 9 here, we get 4 over 2. So that's a 0 over 16 is a 0. 12 over 8 is same as, divide by 4, you get 3 over 2, which is 1.5, less than 2, and that's true. So the answer is x is greater than 8 is not equal to, better make sure it's an 8, or we could have open at 8 going to infinity. You could have that. So 8 marks altogether, but again, I caution you, when you have inequalities with fractions, denominators, rational expressions, you got to be careful. You should check the answers we get, like 9, 2, and 0 into the main equation. If you didn't, you put the 0 in here, you would have got a plus and you would have picked it. Why? Because it's greater than. So just be careful. And we have 8 marks, so the 8 marks are going, LCD is a mark. If you got this equation here, you got a mark. If you simplified it down to here, you got a mark. And if you picked up the two solutions here for 8 and negative 8, this one, if you got rid of the negative and changed the inequality, if you got your two values of x, you got a mark. And if you did each of these, that's 1, 2, 3, 4, 5. If you did each of these correctly, you got 2 marks. And if you got the answer correctly, 8 marks in total. But again, cautious. Cannot have a negative in the fraction of an inequality. That's why we check back into the main original inequality before we start. Now solve. Again, we have an inequality that's greater than equal to. So we have to simplify each side. So when I do this, I like to multiply my binomials first. So that's x squared. That's a plus 3 minus 1. So it's a plus 2x. Negative 1 times 3 is negative 3. And we have multiply here, we get 4x squared minus 4x plus x. Continue to multiply because I multiply the binomials first and then the monomial after. I find that's just a habit I have. If I multiply right, I like to multiply again these two binomials and then the x after. But you could multiply x by x minus 1 and then take that solution and multiply by x plus 3. But again, the two binomials first and then the monomial second makes it better. I find it better anyway. So that's simplified so far. Each side is simplified. Now we have it. We have to make it equal to 0. So we got an x cubed plus 2x squared minus 4x squared minus 3x plus 3x greater than or equal to 0. They cancel out. So it gives me x cubed minus 2x squared greater than or equal to 0. We have a cubic. A cubic got 3 brackets, 3 solutions, I should say. Let's see. Notice I have an x common, but the x squared is in both terms, so I take the x squared out to get x minus 2 greater than or equal to 0. Now we have x squared equals 0, x minus 2 equals 0. So x is 0 or x is 2. I use an equal sign here. I get the zeros of what values of x will give me a 0. So on the number line, we have the number line here now. I draw the number line. I have a 2 and I have a 0. Notice we have equal to 0, so we're allowed to have the 0. And we're allowed to have the 2, so they're solid. And if you think about it, let's try a 3, a 1, and a negative 1. So if you take the 3 and sub it in here, a 3 makes 3 squared is positive. A 3 right here is 1, which is positive. So a positive times a positive is a positive. We have a 1 going in. 1 squared is positive. 1 times 1 subtract negative 2 is negative, so that's a negative. We put a negative 1 here. We get negative 1 squared is positive. A negative 1 subtract 2 is negative. So that gives us a negative. So greater than equal to. So greater than is a positives and equal to. So we're selecting the positives. So we're selecting this direction here along with the 2. And since this is negative, we can't take it. Since this is negative, we can't take it, but we have to take the 0. So we got x equals 0, or x is greater than or equal to 2. And again, if you want to name this one a little bit different here, you can go 2 is as a square bracket this time because it's equal sign going to infinity. So either or. And that's 7 marks. And again, if you simplify this expression to each of these to this step, you get a mark each. If you simplify it to here, you get a mark. If you solved and got the 2 values, you get a mark. And that's 4. If we did this solution here, we get a mark. And if we wrote these 2 answers, you get 8 marks in total. Check it out. You get 8 marks. Oh, 7 marks, sorry. But anyway, if you get the final answer, just give yourself 7 marks, or say to yourself, I know what I'm doing. Now, here's another one. I made up this one similar, but yet different. The negative x plus 4 is in between, so we have 2 less than negative x plus 4, and that's important. We have negative, better be careful, negative x plus 4 is less than or equal to the absolute value of 3x plus 2. So this is in between the 2, so we have one side is right here, and this is the other one here, and there's an and, because this numbers we picked have to satisfy this one and this one, both of these and both of these. So we vary this. We can go negative x plus 4 is, if we want, we can go, this is greater than 2, so negative x is greater than 2 minus 4. Negative x is greater than negative 2. Divide by negative. X is less than 2. So we have this one solved out. Now we have to do, so the and is coming down through here for every step. Okay. Now, I want to do this one. What I like to do is have the absolute value on the left side. So the absolute value of 3x plus 2. If that's less than this absolute value, that means the absolute value is greater than, equal to. Like if 2 is less than 10, when you switch it, 10 is greater than 2. So that's what's happening. Notice I have an absolute value, and with the absolute value, I go negative of the 3x plus 2 is greater than or equal to negative x plus 4. Because it's a greater than, we have an or. And the positive of, positive, not negative, of 3x plus 2 is greater than or equal to negative x plus 4. So we have, because we have absolute value, I do the negative of this binomial and the positive of it, not changing the greater than equal to. Notice, all I do is keep it in the same order, keep the same symbol, and I go to negative of it and the positive of it. Then I simplify it. So I can do negative 3x minus 2 greater than or equal to negative x plus 4. Negative 3x plus x is greater than or equal to 4 plus 2. Negative 2x is greater than or equal to 6. Divide by negative 2. And we have x is less than or equal to negative 3. And we go with an OR coming down through here. We're going to solve this one as the positive, so it's 3x plus 2 is greater than or equal to negative x plus 4. 3x plus x is greater than or equal to 4 minus 2. 4x is greater than or equal to 2. Divide by 4. X is greater than or equal to 1/2. So if we take all of these and have a number line, the number line has the furthest integer or rational number on the right side is negative 3. Then I have a half, and then I have a 2. Put them in that order. So this is an and, so this and keeps coming down here. I could write it out, keeps coming right down. This is an and all the way down through. So let's graph this one. X is less than 2. X is less than 2 is not equal to 2, is less than 2. If you look at the graph of these, like I'm doing, and you pick up the intersections, I find that's faster. Now I'm going to look at this one right here. We're going to graph this OR. So x is less than or equal to negative 3. So it's equal to negative 3. So it's a solid dot and less than. And right here, x is greater than or equal to 1/2. So equal to 1/2 is a solid dot and going to the right. So what you have is you're doing an intersection. So you're getting the solution to this and the solution to this. So the solution to both of these, when we put them, is what we have. I do this. So these numbers are in both sets, and these numbers are in both sets. So this one is, that's x is less than or equal to negative 3. And this one is, right here, is 1/2 less than or equal to x less than 2. You can't have 2. 2 is hollow. This is solid. So you're going to have equal to 1/2, not equal to 2. And this is the intersection. So it's this. So the solution are these numbers to the left of negative 3 and negative 3, and between 1/2 and 2, including the 1/2. And again, that solution, you could write this one down as starting with, it's a square bracket, negative 3, and it's going to the left, so that's negative infinity. Or, and this one is equal to 1/2, so it's a square bracket, 1/2, comma, 2, and the 2 is, this is square bracket means it's equal to, the round bracket means it's not equal to. And we have 9 marks. So if you wrote this line down, you give yourself a mark. If you stated it as this, you give yourself another mark. If you solved it down through here, you get another mark. And if you solve as you go down through here, if you wrote this one as the plus and the minus, you give yourself another mark. And you got the 3 and you got the 1/2, some more marks. If you did the graphing correctly, you did another mark. And if you wrote these two answers, you got 2 more marks. Just check it, 9 marks in total. So if you have this correct, we have written down as a graph, or have it written like this, you got your 9 marks. And we have one more to do, solve by graphing. Notice we have 2 equations, 2 inequalities, because this is a greater than and this is a greater than. But the first one, 12x minus 4y greater than 12, this is the linear, so I'm going to solve it for y equals mx plus b. So I move the negative 12x to the right, make it positive. The 12 is already there. Divide by negative 4 into every term. So I got y is, because I'm divided by negative, that's a less than. And I have negative 3x minus 3. So what I'm going to do now is I'm going to graph that. So that's a y equals mx plus b, which is a line. So the slope is -3, which is -3/1, and the y-intercept is -3. But the line is not solid. It's less than. So the y-intercept is -3, and the slope is up, or you could go down 3 and right 1. You could go down 3 and right 1, or you could go up 3, left 1. Your choice. So this is, this is a broken line. It's not, the boundary line is not solid. So there it is there. Again, that's the boundary line equal to, but the boundary line is broken. And less than is below. So I'm going to shade that less than in green. I'm going to shade this in green because like this. So you're below this line. Another way to check, notice if you take 0, 0, checkpoint, put a 0 in here and a 0 in here, 0, and this is -3 times 0 is 0, and 0 minus 3 is -3. 0 is less than -3. No, 0 is greater, so you can't shade on this side, so that's why we're shading on this side. That's another way to check. Check a test point. Test point is 0, 0. 0, 0 doesn't work, so it's on the other side. You have to shade. Okay, now I'm going to work on this one. And this is, I have to simplify the equation. So I'm going to multiply the brackets. Negative x times x, negative x squared plus 4x plus y greater than 4 times x plus 2 is 4x plus 8 minus 9. And notice I have all the terms, so I'm going to solve it for y. So move the x squared over and make it positive. Minus 4 plus 4. And I have a plus 8 minus 9. So I moved the x squared over and made it positive. I moved the 4 over and made it negative. And these stayed positive and negative accordingly because I didn't move them. So I got y is greater than x squared, and they cancel out, and I get a minus 1. Oh, minus 9. Now, why did I put the 9 there? Just something that I do. One of those little errors I always make. And students remind me, so you made an error. But it's a simple error, but if you don't do it right, you get the question wrong. So this is an inequality greater than, but it's, notice that this is a parabola. And so we got to graph this parabola. So that means if I go y is equal to x squared minus 1, and that's y equals x squared plus 0x minus 1. So I have the vertex of the parabola is that x is equal to negative b over 2a. So b is 0, so it's the negative of 0 over 2 times 1. So that's 0 over 2, or 0. So the x-coordinate of the vertex is 0. And we sub that in. We sub 0 in. We get 0 squared plus 0 times 0 minus 1. So I'm subbing the 0 into this equation here or into this one. Makes no difference. If I sub it in here, I get less work. I put it in here. I should have put it in here. I got 0 plus 0 minus 1. Minus 1. So the vertex of the parabola is 0, negative 1. So the vertex of the parabola, I'm going to do that parabola in red. So the vertex is 0, negative 1 right here. Now, I got to find the x-intercepts. That's already a y-intercept. So let's find the x-intercepts. So let's make y equals x squared minus x. Let's make y equal to 0. So we have x plus 1, x minus 1 as factors. So that means x is a negative 1 right here, and x is 1 right here. So that means when we have x is negative 1, y is 0. When we have x is 1, y is 0. So x is 1, y is 0. X is negative 1, y is 0. So both the line and the parabola intersect at this point, but not at this one. Now, we have, how we're going to find, we have the parabola like this. Parabola is doing this. Notice this parabola is positive, is opening up. But what we don't know is that when I come over here, I know it's cutting through here, but where's it going to hit up here? Is it going to hit up here or here? So what we do, you take the two equations, which are these two inequalities, and make them an equation, and go x squared minus 1 equals negative 3x minus 3. You let this part of the equation right here equal this part, as if you had two equations. And you get x squared plus 3x minus 1 plus 3 equals 0. X squared plus 3x plus 2 equals 0. Again, it's a quadratic. X, factors of 2 are 2 and 1. Product is positive, sum is positive, so plus 2 plus 1. So that means here x is negative 2. And right here, x is equal to negative 1. And we take the negative 2 and sub it into whatever one of these equations you want. It makes no difference. You can sub it into here or here. So we put a negative 2 right here. Negative 2 squared is 4. 4 minus 1 is 3. So this is an ordered pair of negative 2, 3. And we got x is negative 1. That's already right here. So you know that y is going to be 0 for that one. Or we just take the negative 1 and sub here. Negative 1 squared is 1. 1 minus 1 is 0. So we already have it right there. So these are the 2 points that the parabola and the line intersect. We got one of them. And the other one is a negative 2, 3. Right here. So the parabola goes up this way. It's and then goes on like that. It goes on now. The boundary line is the equation says greater than, so the boundary line is broken, not solid. So the solution is we have to take the parabola, and we have the parabola drawn, but what I didn't do is shade in where y is greater. So y is greater, and again the test point is 0, 0. You put a 0, 0 in here, and you get 0. You get a 0 here, so 0 is greater than negative 1. That's true. So in relation to the parabola, we're shading here. There it is. So the solution is all the points below this line and all the points in, if you want to say, inside of this parabola here. So that means that the solution is this shaded region right here. I'm trying to make it dark. There it is. All the points. You can't say the solutions are all the points that fit between negative 1 and 2, but you can't name them all. You can't name all the points. So the solution to this system, the solution is the double shaded region, but not the boundary. But not the boundary. None of the boundaries are there because this is a greater than, this is a greater than or less than. There's no equal sign, so the boundaries are not included. So the solution is the double shaded region, or the dark area here. And we have 9 marks, then the 9 marks are spread throughout here. But as long as you get 1 mark if you did this, you get another mark if you simplify this equation to here, and you get another mark if you picked up the vertex and you did all this work here. And if you graphed the two of them, you picked up the vertex and all that. So if you did this graph correctly, you picked up those 3 points. You picked up 2 marks for graphing this line as broken and shading below, and you get 2 marks for shading the parabola with a broken and inside of here. And if you solve and got all the points of intersection, which is where the 2 lines are, because you got to pick these 2 points where they intersect. So if you get a mark, and if you shade it, you get 2 more marks, so 9 marks altogether. But you can see if you have something looking like this and close to it, then give yourself 9 marks. I distribute the marks. If I were doing a test, I would distribute the marks. You know, I just wouldn't say this is 4 marks and there's the end 4 marks. I always give marks going through for the credit of the workings and showing things. So that brings us to the end of the video. And if you like my video, click the like button. Click the subscribe button if you want to be a subscriber. Visit my math website, www.mathfullyexplained.com, to find more information about me, my videos, and the content that's on my YouTube channel called Math Fully Explained. Thank you for viewing my video. Hope the video was of some help to you. Bye-bye.